Okay, Collins Maths Frameworking, book 3.3, chapter 12, compound units. So 12.1 is speed. Now, the book comes on to this triangle a little bit later, but I think it's good to start off with this idea of the triangle when you've got compound units. And you have one thing at the top and then two things at the bottom. Let's just split that up. So for speed, you have your speed here, and that is distance over time. Let me explain that a bit more. To get one of these to work out, say, the speed, you do the distance travelled over the time it took. Okay? If you want to know how far you've gone, it's the speed you were travelling at and for how long. And that might be quite intuitive. So we normally talk about speed in kilometres per hour. So the distance would be kilometres, the time would be hours. So the speed would be, divide that by that, and you end up with kilometres per hour. If you want to know how far you went, well, I was travelling at 60 kilometres an hour for 2 hours. Speed times time, 60 times 2, I did 120 kilometres. And that's pretty simple. However, the book does make it a little more complicated. So example 1, car travels 28 kilometres in 15 minutes. And then it says, what's the speed, the average speed in kilometres per minute? So the speed is 28 divided by 15, which works out as a funny number, but it's 1.87 kilometres per minute to 2 decimal places. A bit of a weird way of saying it. You wouldn't normally talk about kilometres per minute, but hey, that's what the book asked for. And then the example B says a runner runs 10 kilometres in 1 hour, 37 minutes. What's the average speed in kilometres per hour? Well, we've got to do 10 divided by, and we've got to put a number here. That's the thing about time, it's not in decimal, is it? So we've got to work out what this is in a decimal. Well, the 37 minutes, that's 37 over 60, which, if you do it on a calculator, is 0.616, and then the 6 goes on forever. But there's 1 hour as well, so you've got to add on the 1, so plus 1, 1.616, recurring. Okay, so now what we need to do is, that's how long it is, so remember it's speed, it's distance over time, so the 10 divided by the time, 1 hour 37, but as a decimal it's that, 1.617, because it's 6 recurring. But if you can leave it in your calculator, that will be more accurate. And then that works out to be 6.19 kilometres per hour. Again, rounded to 2 decimal places. And the book reminds you it's best to leave rounding till the end. So if you can leave this number in your calculator, it will give you a more accurate answer. And if you round earlier, you may find your answers are slightly different to the book because of that rounding error. Okay. Now, sometimes it's going to ask you to change from, a speed is often meters per second in physics, or we sometimes talk about kilometers per hour when we talk about driving. Rarely do we do kilometers per minute, but still. So here's the question, how do we change from, in fact, example 2 is asking, a car is travelling at a constant speed of 95 kilometers per hour. What is that in meters per second? How do we change it? 95 kilometers per hour. How many meters per hour? Do one bit at a time. Let's change it to meters and think about that first, and then do the per second. So in 1 hour it travels 95 kilometers. in 1 hour, how many meters will it travel? Well, in each of these kilometers is 1,000 meters. So we times that by 1,000. But then we want to know per second. So we've got to split that up into all the seconds that are in an hour. And 60 times 60 is 3,600. And you can actually cancel that down a bit. So those 2 zeros can be cancelled straight away. So it's 950 divided by 36, which works out to be 26.4 meters per second. That is rounded to 1 decimal place. Okay, and then that's part A of example 2. Part B is, how long does it take to travel 100 meters? So that's helpful because we've now got it in meters per second. Well, let's put our triangle back up here. Distance, speed, time. We want to know the time, don't we? Time. So it's the distance divided by the speed. So 100 meters divided by 26.4. Just looking at that, that's going to be nearly 4, isn't it? A bit less than 4. Let's have a look. It's 3.8. You stick that in your calculator. 3.8 seconds. That's to 1 decimal place.